Action. Here we go. Yes. Okay. Tell me about number one, Ty. It's a function. How do you know it's a function? Okay, so you looked here to know it was a function. So since you know it's a function, tell me the answer choices you can eliminate. Good. Then you have to decide which one is correctly mapped, and which one would that be? B. Very good. I did not assign number two for you to do last night, so I'm going to work it for you now. It says evaluate f of x equals negative 4x minus 3 for x equals negative 3. That just means you're going to plug in negative 3 for x in the problem. Now remember, this part doesn't have any mathematical meaning at all. That f of x, that f of negative 3 is just a label like the y. This is the math you need to do. Multiply the negative 4 times the negative 3. It's going to give you 12. 12 minus 3 is 9. So that answer is 9. Anybody have a question on that one? Number 3. A taxi company charges passengers. Yeah, I jot it down as we go. What? Yes, sir. I would jot these down as I go. Now, you know I'm going to post the video so that if you get behind, don't worry about it. You can fast forward to that spot. You can turn the video on mute. The audio is always shaky anyway, but you can see the process. The rule, they give you the rule. They charge you $1.25 plus 25 cents a mile. Straighten up. Then they tell you to figure the cost for 1 mile. So it's 0.25 times 1 plus $1.25. When you do that, it's going to turn out to be $1.50 because it's just a quarter added to $1.25. But the next time they ask you to figure the cost for traveling 2.7 miles. So you're going to probably need to use your calculator here. And you can just enter that. Yes. Not if you use the multiplication button. No, I don't. I use them because it's got that 0.25, that decimal, because it's money and it just. But you could write it with a multiplication symbol. No, it's 2.7 miles. They charge you 25 cents a mile to ride in the taxi. And the first one, they just went a mile. The next time, they went 2.7 miles. So then it comes up to be this when you add it up. And it's money, so they're going to go ahead and round up to the next whole cent. So it's $1.93. No, they don't charge you $1.50 per mile. They charge you a quarter per mile. Okay, so the first time I went 1 mile, so it's 1/4 plus the $1.25, kind of like the upfront fee. The next time I took a quarter and multiplied it by 2.7 and then added the little fee. Okay, the calculator did it, but that's what happened. Okay, the next ask you to graph. So they give you this equation, y equals negative 4x minus 3. Does it say plus 3? It sure does, doesn't it? And you need to make a table. And remember, you get to pick your numbers, and you should pick the easiest numbers you can think of, which would be, yes, sir. I'm only going to require you to have 3 numbers. So we're going to plug it in to the problem. It's going to be 4 times negative 1 minus 3. What is that? Oh, because my brain's not working. Thank you, sir. What's 4 times negative 1? Plus 3. No. Negative 4 plus 3. Good. 4 times 0 plus 3. 4 times 1 plus 3. 7. All right. All right, here we go. I don't know if I left enough room or not. Negative 1, 0, 3, 1, 7. Oh, barely. I don't know if it'll ask you if it's linear or not, but it is. Question 5 asks you to graph another one. What's the difference between 4 and 5? Absolute value. Okay, choose some numbers for x. That's fine with me. So this is the absolute value of negative 1 minus 1. What's the absolute value of negative 1? And 1 minus 1 is 0. Absolute value of 0 minus 1, negative 1. And the absolute value of 1 is, the absolute value of 1 is 1. And then take 1 away, you get 0. Well, hang on, one at a time. Let's graph it, and then you ask your question. Negative 1, 0. 0, negative 1. 1, 0. It is a function, but it is not linear. It is V. It's a V-shaped. It does have 2 U's in it, but that's the rule. Okay. Back to the handout. The next one's not on graph paper. Number 6 says, write a function rule for the table. You have to ask yourself, if I start with negative 1, how can I end up with 4? I could add 5. Or what else could I do? What can I multiply by? Okay. If I start, 0 is not going to help me figure anything out. I'm going to go on to the next one. 1 plus. Oh, okay. It'd have to be a different number. So you're saying do what now? Okay. What about the 2? It works there too. So they're writing with f of x, and they want you to multiply by negative 4. Now, you can write x times negative 4, but the typical way to write it is negative 4x. 7. What are we doing to change the first number into the second number? You think we're adding negative 2? Adding negative 4, so you could write x plus negative 4. Could you also write this? Subtract 4. I think they mean the same thing. Okay. Number 8. Write a function rule that gives the total cost, C of P, of P pounds of sugar if each pound costs 35 cents. So what would you write here? C of P. Now, how are you going to determine the cost of an amount of sugar? Okay, so it's 0.35 times P. Question number 9. Use inductive reasoning to describe the pattern. Then find the next 2 numbers. Kylie, what are they doing here? Kylie, what are the next 2 numbers? 12 and 8. Okay. Number 10. Back to the graph paper. It says graph the relation in a table. -2, 3. Where does it go? There. 1, 5. 3, 1. 4, 5. Is this a function? Now, what do you look for to determine if it's a function? Hang on, I'm going to call on somebody. I'm glad you know, but I'm going to call on different people. And you've answered too. I'm going to call on Roland. How do you look at this? What do you look for to determine if it's a function? If the x numbers are the same, what does it cause to happen in the graph? They're stacked. So a vertical line will touch them twice. Does that happen anywhere? So this is number 10. Yes. No, sir, it's not linear. 11 says, write a rule for the linear function in this table. Now, I'm going to call on somebody. What are we doing here, Landon, to turn the x into the f of x? Plus 4. That's all they asked me to do, was to write the function rule. Number 12, label each section of the graph. This is what I want you to do, okay? This is speed and time. And at the beginning of the story, was this roller skater stopped or were they already moving? How do you know? Okay. So now, thank you. So number 1, he was slowing down. Okay. This is section number 2. So let me call on somebody. Heath, in section number 2, describe what's happening. All right. Speeding up. Now, this part at the top is what I'm going to call number 3. And and he's not sitting still. I don't want you to think that. Well, it's not. I don't want you to think it's flat. Over here, it's going to be flat. That's his fastest speed at the whole graph, right? What's his fastest speed? Hey, straighten up. What's the fastest speed? It happens at 3 because it's the highest point on the graph. That's the part I want you to pay attention to there. Fastest speed. Section 4. He is slowing down. Now, y'all been waiting on this one. 5. Constant rate. He's not stopped. If he was stopped, he would be where? At 0. But he's going at a constant rate. Yes. I don't know. I have to check into that. Model the function rule with a table of values. If you use -1 for x. Okay, take your calculator. We're going to do this one on the calculator. Everybody take your calculator, go to y equals, and make sure this screen is clear. You don't need any of those plots selected, and you don't need anything in y equals. And we're going to enter that function. It says -3x minus 1. Be careful that you use the button for negative at the beginning, and you use the subtraction button between the two. One of them is shorter. Be sure you pay attention to that. Now, we don't want to look at their graph. That's not what I want you to look at or focus on first. I want you to go to their table. So press the blue button for second and the graph button that'll take you to the table. I want you to move around until you can see the parts that are important for this problem. Question? Second graph. Hang on, one question at a time. Stop. Question? That blue function is, see, it says table in blue. Yeah, I know some of them are in better shape than others. At -1, what's the y value? At 0 and at 1, -4. Okay, now I think you're better off to graph from that table by yourself. You can compare it in a minute to the calculator. -1, 2, 0, -1, 1, -4. Not right this minute. Hang on. Hang on. Let's finish this problem. Hit the graph button if you want to compare. You can see it's linear. Now, do you have a question about this problem? Yes, yes, it does. Positive. This is 0, 0 right here. Well, x is negative, okay? But over here, x is 0, and here, x is positive. These negatives under the y category tell you whether you're in the top half or the bottom half, okay? In this section of the graph, both of your numbers are positive. In this section of your graph, x is negative, y is positive. In this section, both are negative. In this section, x is positive, y is negative. Okay, does that help you? Okay, moving right along. 14. Elaine is in the business of repairing home computers. She charges a base fee of $35 for each visit and $40 per hour for her labor. The total cost for a home visit and X hours of labor is modeled by this function rule. Use the function rule to make a table. Okay, let's do this one in the calculator again. Almost her name. Not quite, but close. Oh, I pressed y equals, and then I cleared anything that's in there. And we're going to enter that function, 35 plus 40x. 35 plus 40x. Now, it's most useful to me to use the table. So I'm going to go second graph. It's going to pull up the table. Now, the negative numbers don't make sense in this problem because this is a real world problem about somebody who's hiring a computer repair person. But they do want us to start by recording the amount of money you would spend if it were 0 hours. So what is that? 35. And if it were 1 hour, 2 hours, and 3 hours. How much do these numbers go up by? 40, because that's what you multiplied by. Okay, when you go to graph this, it's perfectly fine on the x-axis to use 0, 1, 2, and 3. But it doesn't make sense on the y-axis. We're going to have to adjust our scale. We could do by 15s. 20s. Okay, we'll do by 20s. I think 20 because our numbers are going to be a little more spread out. So this is 20, this is 40, 60, 80, 100, 120, 140, 160. Okay, so at 0, where would I put my dot? 35. Close to 40, but not on 40. After 1 hour, where does that dot go? Okay. After 2 hours, Heath. Okay. After 3 hours, Zoe. Here. Can you see? Yes, 155. Now, does it look like that's linear? Yeah, it's linear. Okay, 15. Find the range. Go back to your calculator. Find the range. Guys, those are the y values for this domain. These are the x values. Go back to your calculator. Go to y equals. Hit clear. Enter your function. 3x minus 5. Go to the table. Now, they're not all in order. They're close, but they're not all in order. But we need to know what is the range that's associated with -2. 11. What is the range that is associated with -1? What's the range associated with 1? And the range associated with 2? 1. Does anybody have a question on how to find the range? We could have made a table. I don't think anybody has any trouble making a table. I'm kind of going over the calculator skills with you because as you get closer to the exam, you want to be sure you have a way to make sure you're accurate. Anybody have a question over these steps? We good so far? All right, let's go to the next question. It should be 16. Use the vertical line test to determine whether the relation is a function. This one's a function. 17. Ty, tell me about 17. Tell me why. So these 2 points cause it to fail as a function. 18 asks you to identify the domain. Those are the x values. So what are they? Okay. And the range. But you just listed once. Questions on number 18. All right, 19. Sketch a graph of the speed of a city bus on a daily route. Label each section. The bus pulls away from a stop. Okay, if it's stopped, then the speed is 0. So it's going to start here. And it increases speed. Yes, I know. It's been at a bus stop letting kids on. But how fast was it going when kids were getting on? 0. Okay? It was going 0 when kids were getting on. And then it pulls away and it increases speed. So, yes. I tell you what I want you to do. I think that's a really good math question, but when we get through, I want you to email it to me so I don't miss out on any of the parts, okay? Part B. Part B, let's go. Bus is at a constant speed. Straight line. The bus is stopped. So we're back down here. He had to slow down somewhere to get stopped. He stopped for a minute, and then what happens? Okay. Number 20. This table shows how much a carpenter charges for work. Is this data linear? Linear should increase by the same amount. When the hours increase by the same amount, it should have the same relationship here. This is the stretch problem. This is kind of the challenging problem. How much does it go up from 25 to 40? How much does it go up from 40 to 60? Okay, now how much are these going up by? Every time, right? So is 15 the same change as 20? No. So this is not linear. Now let me show you an example. If I took this whole first part out, and these are going up by 20s, right? And then if I jumped ahead and I put a 6 here, and I put 120 here, how much would this go up by? 40. And how much would this go up by? 2. If you're going up $20 every hour, and then you go up $40 for 2 hours, is that the same relationship? Is $20 for 1 hour the same relationship as $40 for 2 hours? Yes. So you would say, yes, it's linear. That's kind of a stretch. Okay.